Hi students, we are going to take a look at how we can prove that conjectures are true or valid. And as you've seen before, when you're talking about conjectures are based on patterns. You can prove them false with a counterexample, but to prove them true, you need a concrete example or you need a formal proof. Remember that no amount of numeric examples will prove a conjecture to be true. So we're going to look at 3 different conjectures. Each one is going to be a different screencast. If you have not printed out the note sheet, I encourage you to do that and work along, keep notes, try things on your own as we get into the other examples. So we're going to start on this first one. Okay, so we are going to be starting with a concrete example. And concrete examples begin with a numeric example. So we're going to look at our conjecture. The sum of any 2 consecutive numbers is an odd number. So I'm going to start with a numeric example. I don't want it to be too big because that's cumbersome. But I also don't want it to be too small because sometimes it's hard to make the generalizations that we need to make if it's too small. So I'm going to do, I think we'll do 4 plus 5. Okay? And we know 4 plus 5 is equal to 9, and we know that 9 is an odd number. Great. That's one numeric example that certainly doesn't prove this conjecture at all. We could do, 100 2 consecutive numbers and say, hey, it's odd, and still nobody cares. Okay? So what we have to do is turn this numeric example into a concrete example. And we're going to do that by representing both of the numbers. So I'm going to represent 4. I'm going to represent 5. And when you're adding, essentially you're going to take all of the objects in both circles, you're going to move them down here, and you're going to count those up, and that's your sum. That's your answer to an addition problem. Now, the trick in a concrete example is how you go about moving these objects down into the circle that represents the sum. If I just drew 9 x's down here and counted them up and said, hey, look, it's 9, that's no better than me saying 4 plus 5 is 9. So this is the really critical part. So what I have to do is say, all right, I want to prove to people that the number I get is always going to be odd. And after you do a few, you kind of learn the tricks. So I am going to move my x's down to my circle, and I'm going to move them down there in pairs. And the reason I'm going to move them down there in pairs, so I'll put a circle around those, is because if I am able to pair things up perfectly, then I know a number is even. And if I'm not able to pair things up perfectly, then my number is odd. There's an odd man out, essentially. I'm going to make another pair. I'm going to make, I guess, a square around this pair. I have a feeling I'm going to quickly run out of shapes. So we'll try to make this one look a little bit more square. Right. So I've got another pair. So far what I have down here, I don't even care how much it is, but I know it's even because I have 2 perfect pairs. All right, I'm going to take another pair. These are my triangles. So here's my new pair. My triangles around them. All right, I'm almost out. I guess I'll make a squiggle around this one. And I'll take this guy here and make a squiggle around it. All right, so what I have down in this circle, again, I don't care what the actual quantity is, but I can see by looking at it that everything is paired up. It's an even number. I know that for sure. Well, when I go back up top here to try to make another pair, I don't have any more left in this circle. I come over here and I have one more left. I take this one and I move it down. I can tell without counting that what I now have is an odd number because I have all these perfect pairs, but then I have this guy all alone, and that makes my number odd. Now sit and think about the process we went through. There were 4 x's here. There were 5 x's in the second circle. I brought them down in pairs. Shouldn't be any surprise that since these are consecutive numbers, when I run out in the first circle, I'm going to have 1 left in the second circle. That 1 left will come down and will make my sum odd every single time. So imagine I have 113 plus 114. I would go about making pairs 113 times. When I run out of x's in the first circle, I will have 1 left in the second circle. It will come down to my sum and it will make it odd. So when you do a concrete example, you need to follow up with that type of sentence. Okay? So I'm not sure I'm going to be able to write this very neatly. I'm going to give it my best shot here. I'm going to pause, write it, and then come back in the video. All right, so my apologies for the messiness, but I did try to write it down. I'll read it to you. So I pulled them down in pairs, 1 from each circle. When I run out in the first circle, I'll have 1 left in the second circle. That leftover makes the sum odd. So that would be what I would consider full credit for a concrete example. Okay, so now we're going to come over here and I want to work on the formal proof. So the formal proof involves variables. So what I have to do is I start a formal proof the same way every time. I'm going to say let n equal a natural number. Right? Natural numbers, okay, by definition, are the numbers 1, try down here, 1, 2, 3, 4, and so on. Okay, so we're going to say, hey, let n be a natural number. Then I need 2 numbers, so I need 2 consecutive numbers. So if n is my first number, n plus 1 is the next number. Right? So now I'm going to find the sum of those 2 numbers. N plus n plus 1 is equal to 2n plus 1. All right, so now I need to convince people that I know 2n plus 1 is odd. If you think about it, we know that. Because a multiple of 2 is even. Okay? So think of any natural number, multiply it by 2, and you always get an even number. When you double a number, you get an even number. All right, so if you are an even number and you increase by 1, well, that means that's going to pop you over to being an odd number. So if you're at 6 and you add 1, you're at 7. If you're at 16 and you add 1, you're at 17. So I can write here adding 1 makes it odd. Right? This is a formal proof. I know it doesn't look like what you did in geometry, but it is a formal proof because we have shown for any natural number, all right, if you add that natural number and the number that's consecutive to it, the number that you get back will always be an odd number. So if you struggled with this, I would maybe suggest rewatching this screencast. Maybe try to give the second one a try before you watch this screencast and see how you can do with it.